Welcome all. Today's topic laws of motion part 7. Question 1. A block A of mass M1 rests on a horizontal table. A light string connected to it passes over a frictionless pulley at the edge of table, and from its other end another block B of mass M2 is suspended. The coefficient of kinetic friction between the block and the table is mu. This is coefficient of kinetic friction. When the block A is sliding on the table, the tension in the string is. These are the options. Let's see the answer. Given this is block A which accelerates like this, the tension in the string T, this is pulley, and this is kinetic friction. This acts like this. What do you mean by kinetic friction? The kinetic friction is a force which prevents the object from motion. The object is already moving. The difference between kinetic friction and static friction. What do you mean by static friction? Static friction is a force which prevents the object from motion, which the object is at rest. So here the kinetic friction prevents the object from motion, but this accelerates like this because and the block B is suspended here. The acceleration of block B is downward, and T tension which acts upward, tension T which acts upward, and downward forces mg. Now what we have to find? We have to find the tension in the string of both block A and block B. So here block A, T minus kinetic friction is equals to ma. How we obtain this means T is greater, the force T tension in the string is greater than kinetic friction because it accelerates this side. No. So here T is greater minus, though this force is less. Hence here we put negative sign. T minus kinetic friction is equals to ma. Ma means force, net force. So this is from here we are going to get the equation 1. From this we are going to get the equation 1. We bring this kinetic friction this side. So T minus ma is equals to kinetic friction. So this is equation 1. Block B, here m2g minus T is equals to m2a. Mass of block B, it accelerates downward, so tension in the string is less, though it accelerates downward. Hence tension in the string is minus, mg downward force is greater, hence it is positive. So plus mg minus T is equals to m2a. This is force. So this is equation 2. Adding equation 1 and 2, we get m2g minus m1a is equals to m2a plus kinetic friction. We cut both the t's and we obtained this equation. Now the formula for kinetic friction is equals to coefficient of kinetic friction into normal force. So here the normal force is equals to W. W is equals to weight is equals to mg. So normal force is equals to mg. So at this case, why at this case the normal force is equals to mg means here the vertical acceleration is equals to 0. Only horizontal acceleration takes place. And what happens? The vertical equilibrium takes place. Normal force pushing upward, downward force mg are at equilibrium. So there is no vertical acceleration, and it is on a horizontal surface. The surface is not inclined or bent. It is in a frictionless horizontal surface. Hence n is equals to mg. From here we get kinetic friction is equals to coefficient of kinetic friction into mg. Then move all the g one side and all the a one side. So this will come this side and this will come this side. So m2g minus mu k m1g is equals to m2a plus m1a. Then taking g as common and here taking a as common, then what happens means keep this a here, bring this m2 divided by m1, then equation 2 m2g minus t is equals to m2a. Now substitute this acceleration in equation 2. Why we are not substituting acceleration in equation 1? Because equation 1 already contains kinetic friction. So we do not want to complicate. So we substitute acceleration in equation 2. Bring this m2a this side. So m2g minus m2a is equals to tension. Because we want to find the tension in the string. m2g minus m2, substituting acceleration is equals to t. Then taking m2 common, this is g and this is acceleration. G minus acceleration is equal to, bringing this g outside, g ones are g, and then take LCM. Take this minus inside, minus plus is equals to minus, minus minus plus. So t is equals to m2 m1 plus m2 minus m2 plus mu k m1. Cutting this plus m2 and minus m2, we get 1 here. So t is equals to m1 into m2 into 1 plus mu k divided by m1 plus m2 into g. So option C is right. The tension is equals to m1 into m2 into 1 plus mu k divided by m1 plus m2 into g. This is the tension for block A as well as block B, because in the question they have given light sting. Light sting means uniform tension throughout the sting of two masses. So the tension for block A is same as tension for block B. Question 2. A bullet of mass 10 gram moving horizontal with a velocity of 400 meter per second strikes a wood block of mass 2 kg which is suspended by light inextensible string of length 5 meter. As result, the center of gravity of the block found to rise a vertical distance of 10 centimeter. The speed of the bullet after it emerges off the horizontally from the block will be. These are the options. Let's see the answer. Given bullet mass is 10 grams, bullet velocity 400 meter per second, wood block mass is 2 kg, sting's length is 5 meter. Now the bullet with 10 grams initial velocity u strikes the wooden block. The sting length is 5 meter. The wooden block mass is 2 kg. It emerges of the bullet emerges off with final velocity v and its mass is 10 grams. Now velocity of the bullet after it emerges off horizontally from the block will be. This is the question we have to find. According to law of conservation of momentum, total initial momentum is equals to total final momentum is equals to constant. As I told in previous videos, like collision, car clash, or bullet and gun, then status, for all these problems we have to use conservation of momentum. So according to law of conservation, total initial momentum is equals to total final momentum is equals to constant. Total initial momentum is equals to initial momentum of the bullet, that is individual momentum, plus initial momentum of the block. Then total final momentum is equals to final momentum of the bullet plus final momentum of the block. These are individual momentums. Then the formula for momentum is equals to mass into velocity. Bullet mass is 10 grams. Now we have to convert it into kg. So 1 kg is equals to 1000 grams. Then how many kg is equals to 10 grams? So cross multiply, we get 10 is equals to 1000x. X is equals to 10 divided by 1000. X is equals to, now we cut this, we get x is equals to 1 divided by 100. Then x is equals to 400, we are putting 10 to the power of 2. Then we bring this up, we get x is equals to 1 into 10 to the power of minus 2. Then x is equals to 0.01. Bullet mass is equals to 0.01 kg. As of the formula, this is total initial momentum is equals to total final momentum. So substitute all the values. This v is final velocity of bullet. This v dash is velocity of the block. Then for finding the velocity of the block, we have to use this formula. V is equals to square root of 2 into gh. At what case we have to use this formula means when it is a free falling and it should be in vertical direction. The free falling should be in a vertical direction. So it is a final velocity. For finding the final velocity, we can use this formula. We also have to know about v square is equals to u square plus 2gh. Here in this formula, we can find initial velocity as well as the final velocity. So from this formula only, these two formula has been brought up. So v square is equals to u square plus 2as. So what is the condition of using this formula means the acceleration should be constant and it can be in any direction. So v square is equals to u square plus 2gh. Acceleration can be gravity or it can be any other acceleration, but the acceleration should be constant. Here in this formula, a is equals to g. It is a free falling object. And what do you mean by a is equals to g? A is equals to g means its acceleration, the object's acceleration is equals to acceleration due to gravity. So why we put positive here means it falls downward. Why we are putting negative here means it goes upward against gravity. Hence v square is equals to u square minus 2gh. H means height. Again coming back to the formula, final velocity of the wooden block is equals to square root of 2gh. And then applying all the values, gravity 9.8, we take it as 10 into height 0.1. They have given the height in centimeters, so we are going to convert it into meters. So 1 meter is equals to 100 centimeter. So how many meters is equals to 10 centimeter? Cross multiply, 10 is equals to 100x. 100 divided by x, 10 divided by 100 is equals to x. 1 divided by 10 is equals to x. Bringing this up, we get 1 into 10 inverse is equals to x. Then x is equals to 0.1. So b dash is equals to square root of 20 into 0.1. 2 into 10, 20. B dash is equals to square root of 2.0. Final velocity of the block b dash is equals to square root of 2. Total initial momentum is equals to total final momentum. So we are putting the value of v dash square root of 2. Then doing this, we get 4 is equals to 0.01 into v plus 2 into 1 point. The value of square root of 2 is 1.414. So 4 is equals to 0.01 into 2 plus 2 point. Multiplying this, we get 2.828. 4 minus, bring this side, 2.828 is equals to v into 0.01. Then bring this down, 1.172 divided by 0.01. is equals to V. Now removing the points, we get here also we have to remove the point, here also we have to remove the point. 1.72 into 10 to the power of minus 3 divided by 1 into 10 to the power of minus 2 is equals to B. So cutting this, we get 172 into 10 to the power of minus 1 is equals to V. Then remove this, so we have to move the point here. So 117.2 is equals to V, final velocity of the bullet. So this V is final velocity of the bullet. Answer option C is right, 120. The nearest value in the option is 120 meter per second. Thank you. For more MCQs, watch my previous videos.